Topic 7. Technology of installation of building structures. Lecture plan, 2 hours, 1. Composition and structure of the installation process. 2. The mounting adaptability of building structures. 3. Transportation, storage and acceptance of building structures. 4. Preparation of structural elements for installation. 5. Ways to install elements and structures in the design position. 6. Selection of the mounting crane according to technical parameters. 7. Setting and aligning structures. 8. Temporary fixing of structures. 9. Individual and group means of temporary fixation. 10. Permanent fixing of mounted elements. 11. Fundamentals of installation of structures of industrial buildings with a reinforced concrete frame. 12. Installation of structures of civil buildings with a reinforced concrete frame. 13. Technology of installation connections of elements of reinforced concrete structures. 14. Installation of metal structures. 15. Technology of the device of mounting connections of elements of metal structures. 16. Quality control. 17. The main provisions of the safety. Installation process and its place in construction. Installation of structures is an industrial mechanized complex process of construction of buildings or structures from ready-made prefabricated structures or their elements. The higher the factory readiness of structures, the less labor and time is spent on the construction site for the construction of construction objects, the less auxiliary work and organizational difficulties. The complex process of installation of structures consists of simple processes and operations, transport, preparatory, and actual installation. Fig. 1. Protractor processes are delivery, acceptance, unloading and layout of structures, their elements, parts, auxiliary materials and fasteners, as well as the supply of structures to the installation area from warehouses or sites of large-scale assembly. The preparatory processes are production and mounting of fixtures, inspection of the geometric dimensions and preparation of the accessories used, verification of geometric dimensions and quality of the structures and grounds on which they should be installed, pre-assembly and when lifting, mounting and fixing of scaffolding, ladders, fencing, installation of devices for the alignment and temporary securing structures, training and equipment for joints for fasteners and materials for joints, installation, mounting supports and scaffolds, in some cases, control assembly of joints. The actual installation processes are slinging, lifting, installation in place, alignment and temporary fixing of structures, anti-corrosion, protection of individual structural elements or parts of joints, final fixing of structures. The complex of works on erection of buildings and structures, installation of building structures is often done in 2 stages, the installation of underground structures, foundations, supports, channels, wells etc., performed in the period of foundation work and installation of above-ground structures, load-bearing frames of buildings, coatings, communications, walling, partitions, stairs, platforms, etc. The latter is the main stage in the construction of prefabricated buildings. In brick buildings, the installation of above-ground structures is usually part of the main stage of building construction masonry. Installation of structures begins only after a thorough instrumental breakdown of the axes, checking the marks and position in terms of supports and embedded parts. In the construction of industrial structures, the installation process is usually the main one. It has a decisive influence on the overall duration of construction and the organization of subsequent work. Installation of structures is carried out by flow methods with maximum mechanization of transport, preparation and installation works. It is advisable to combine installation and post-installation work on separate installation sites. A typical part of the building is used as an installation section, a block, section, span or cell. The sequence of construction of frames of industrial buildings is established on the basis of space planning and design solutions, taking into account the phased commissioning of the workshops, production facilities and technological sites located in them to ensure the start of installation of technological equipment at the earliest possible time. The sequence of installation of structures within the installation area is set so that the stability and geometric immutability of structures and the assembled part of the building are ensured. Installation of prefabricated structures and is carried out in accordance with the installation diagrams and working drawings, projects for the organization and production of works, including the project for the production of installation works. Project production installation specifies the technological sequence and methods of installation, the type and grade of mounting machines, ways to enlarge designs, partitioning structures for assembly areas, units, tiers, sequence of works, a list and design of attachment, ways of temporary and permanent fastening structures and devices of joints, measures to ensure safe operation. The installation of structures ends with instrumental verification of the accuracy of their installation and compliance with tolerances, quality, reliability, and load-bearing capacity of joints. The project of installation works includes calendar plans for delivery from factories, technological schemes for installation of the building and its structures, schemes for installation reinforcement and equipment, schemes for enlarging structures and sites, stands, for enlarging assembly, installation schemes for installation and movement of installation machines, drawings, diagrams of temporary supports, slinging and mounting devices and equipment, requirements for the accuracy of installation of installed structures and geodetic support schemes, schedules for installation work, use of machinery and transport, additional technological requirements. Copy, fragment, from the construction master plan for the period of installation work. Technological capabilities of assembly machines, obra and devices. Preparation of structural elements for installation. Preparation of structural elements for installation is aimed at performing a number of processes and operations in warehouses or on the ground near the installation sites that can be carried out before lifting and installing the elements in the design position, and which are difficult to perform during installation, carried out mainly at a significant height. The processes and operations performed during the preparation of structures for installation include enlarging assembly of structures from individual parts and rods into whole elements, and from individual elements into enlarging blocks, temporary strengthening of structural elements to ensure their stability during installation, elimination of defects found during acceptance of structures, bringing elements to the position in which they will rise during installation, arrangement of elements to be installed with scaffolds, stairs, fences and other temporary devices, fixing on structural elements of insurance ropes, braces, mounting struts, etc., restoration and reapplication of axial drawings, marks of the centers of gravity of elements, places of slinging, cleaning of elements and their parts from dirt, snow, ice, rust, etc. Preparation of mounting joints and nodes, welding to structural elements of parts necessary for fixing elements. Large-scale assembly of structures is most often used in cases when structural elements cannot be delivered from factories as a whole due to their overall dimensions or weight. At the same time, on buildings, parts of the element shipping stamps are enlarged to the whole element before installation. From precast reinforced concrete structures, it is necessary to make an enlarged assembly of trusses with a span of 24 m or more and high columns. From prefabricated metal structures, trusses with a span of 24 m or more and high columns are also most often enlarged. In addition, it is necessary to enlarge metal crane beams that have a span of more than 13.77 m. Crane beams are also enlarged along the extreme rows of columns with brake structures, horizontal trusses or beams, since the latter are difficult to mount separately from the beams due to their great flexibility. They are enlarged to the installation and trusses of coatings with trusses of light and aeration lamps. Consolidation into blocks is sometimes carried out when installing coatings of one-story buildings on metal trusses and arches. A block the size of a cell of buildings is enlarged from trusses in pairs with their connection by ties, purlins, and in some cases, stamped metal decking or plates made of light materials are laid. There are cases of consolidation of metal structures of coverings in blocks consisting of 2 sub-trusses, 3 trusses and lampposts, runs on trusses, and lanterns and stamped metal flooring. Reinforced concrete trusses and columns with a large volume of work and delivery of their shipping marks to a warehouse outside the building under construction are usually enlarged in warehouses, and from there they are fed for installation in an enlarged form. When delivering the shipping marks of trusses and columns directly to the installation area, they are enlarged at the installation sites. Reinforced concrete trusses are enlarged in a vertical position so that it is not necessary to move the halves of trusses delivered in a vertical position from a horizontal position to a vertical one for installation. As an example, Figure 9.8 shows the truss assembly on the universal stand of the TSNIIP design. The stand consists of a conductor for bringing together the joined semi-farms and a clamp brace for fixing the position of the upper belt. Semi-farms in the place of their joining are fixed in the conductor, and the lower belt is installed on roller supports. With the help of a tie bolt, the semi-farms are brought closer to each other until the gap required by the project is formed. After that, the semi-farms are straightened with adjusting screws and fixed on roller supports that can be raised or lowered, so that the farm can be given a design position with a given construction lift. A clamp is put on the upper belt of the truss, which serves to fix the upper belt and attach stretch marks to it, holding the truss in an upright position. Roller supports are installed between the conductor and the truss support units to ensure free movement of the elements. After welding the nodes, the truss is released from the conductor. The methods of installation of construction elements of prefabricated structures, elements enlarged into blocks, and some structures are installed in the design position in various ways. The choice of method is influenced by a large number of factors, namely, the type, size and weight of the elements to be installed. Enlarged blocks and structures, the size of the objects on which the installation is carried out, the height of the support of structural elements, the permissibility of finding and moving lifting equipment within and outside the mounted objects, methods of feeding, storing and layout of elements at the installation site, possibility of obtaining lifting equipment for lifting the heaviest elements, local conditions of the construction site. Before choosing how to install elements of prefabricated structures in the design position or simultaneously with it, the question of the possibility and feasibility of enlarging individual elements into blocks of structures and structures as a whole is decided. The most common method of mounting structural elements is lifting them off the ground by horizontal movement to the installation site, i.e. installation on weight, Fig. 9.26a*. This method of installation is applicable in cases where the lifting capacity of the crane equipment is equal to or exceeds the mass of the element to be mounted with the sling, and the lifting height of the hook ensures the installation of elements in the design position. The most widely this method is used when assembling the various elements with the help of cranes. Individual vertical elements of prefabricated structures, columns, as well as structures as a whole, power line supports, masts, pipes, etc., or parts of them, sections of bookcases, etc., are installed by turning, Fig. 9.26b, with one face of the support part resting on the foundation or by fixing it to a hinge attached to the foundation. If the face of the support is directly supported on the foundation, it is necessary to protect the support from sliding along the foundation when lifting. To do this, you can use braces attached to the anchors. With this method of installation, part of the mass of the mounted structure is transferred to the foundation, which allows the use of cranes with a lower load capacity than the mass of the installed structure. Masts and other lifting devices can be used instead of cranes to lift structures and structures of high height by turning. In cases where the dimensions of the elements or structures to be installed and the conditions of the installation site do not allow them to be placed on the ground with the support end laid on the foundation, the installation method can be applied by turning and moving the support end to the foundation, Fig. 9.26b*. In this way, you can install the same structures as the turning method. When lifting in this way, structures are laid so that their supporting part falls on the other side of the foundation. The support end of the structure is supported on a cart, trolley or sled by means of a hinge designed so that when lifting to the design position, the support end can be placed on the foundation at the design height. To adjust when lifting to the design position, the support end could be placed on the foundation at the design height. To regulate the movement of the trolley or sled when lifting, their foundations are fixed with ropes in two directions, traction and brake winches. Lifting structures using this method of installation by turning. Heavy load-bearing elements of long span coverings, crane beams of large spans, heavy constructions buildings, consolidation and enlargement of farm units, coatings, conveyor galleries, bridge cranes, and other such structures set way vertical lifting, Fig. 9.26g. In the same way, lift structures that are mounted by the Podroskavaut method and the method of lifting floors and floors. When using the vertical lifting method, a small horizontal movement of structures in the raised position can be allowed, as well as a small turn of them on the weight in the horizontal plane. Lifting structures in this way is carried out by one or two cranes, masts, portals and hydraulic lifts. In cases when the installation area cannot be installed, lifting equipment is placed and mounted structures, and the installation of constructions from the area outside of the building requires a heavy crane long reach hook elements, or their integrated units installed for the engines. Fig. 9.26d. The same method is used in the construction of bridges and reconstruction of blast furnaces, when it is necessary to replace the blast furnace. In this case, the moving method is used to move entire buildings to new foundations over a considerable distance during urban reconstruction. The sliding method can be used in conjunction with the vertical lifting method, for example, when changing coatings, when the trusses are enlarged into spatial blocks on the ground, and then vertically raised outside the building to the installation level and moved to the installation site. The method of sliding can also include a method for installing new coatings for industrial buildings. In this case, the structures of coverings outside the building are enlarged into a spatial block the size of a building cell, and then on mobile platforms, slightly higher than the building supports, they are moved along the rail tracks along the mounted span and lowered onto the supports in the mounted cell. Sliding structures in most cases is carried out using winches. Technology of installation of underground structures. Preparatory work for the installation of foundations and underground structures consists in splitting and fixing the axes, checking the base mark, leveling and preparing the base. The axes are fixed on rags, with two-shift work. Light rags are used, where the axis is fixed with a narrow beam of light. Installation of glass-type foundations. To ensure accurate installation of foundations, the axes are transferred to the pits directly to the installation site and fixed there with metal studs stuck into the ground. Cleaning the bottom of the pit is usually performed immediately before the installation of specific foundations. Self-propelled boom cranes are mainly used for the installation of precast concrete foundations of industrial buildings. Their installation and storage of mounted elements is carried out behind the prism of the collapse of the ground. The foundations of industrial buildings are mounted as follows. Blocks for installation are fed on vehicles, the glass cavity is cleaned and closed with a shield, the blocks are lifted by the mounting loops with slings or traverses, the foundation blocks are guided to the design position by weight. After that, the block is lowered to the prepared base and verified. If the permissible deviations are not observed, the block is raised, the base is corrected and the procedure is repeated. Alignment of the position of the mounted blocks is performed by combining the risks of the axes. With the pins. The correct installation of foundations for vertical and check level. Installation of light and medium foundations, consisting of base plate and block glass produced in the following sequence. Foundations unload in the vicinity of the installation site. Check the inner dimensions of the glass, using templates, plate capture for VET sling, and served by crane to the installation site. Verify an axis on the plate with axis risk block a glass plate connecting by welding of embedded parts, which are then coated with an anti-corrosive material. The correct installation of the foundation is checked with a geodetic tool.